Hope you're doing well. Today we're going to talk about lateral area and surface area of different solids. So what you really need to kind of understand is the difference between lateral area and surface area. So when we talk about lateral area, we're thinking about a label. So almost think of like a can of soup. I think of a can of soup, and if you can imagine a can of soup in your mind, think of the label of that can of soup. Where would it go? And the label only goes around the outside, or what we know as the lateral faces of that can of soup. Now for a cylinder, it's a little different because that outside face is a rounded edge or a curved edge. But what's important is the top and the bottom, those bases, are not included in that label. Whereas if we talk about surface area, I like to think about it as gift wrapping, so wrapping a present. And I have two little kids, you guys know that. So I think about when I wrap their present, I have to make sure everything is wrapped. Every last little surface of that present is hidden by wrapping paper. So I think of surface area as wrapping a present. So we're including all of the faces and the bases. So that's really the main difference between lateral area and surface area. So what I'm going to do is I'm going to talk about a number of different solids and briefly just go through if it was lateral area and surface area, what would be the difference. And then just do a couple of examples, really just two, to show how we would apply lateral area and surface area. Now what's important is that this lesson is a lesson to refer back to if you ever have any questions with lateral area and surface area, like on a test or a quiz, so on and so forth. So let's get started. So first we'll go through our different prisms. So the three prisms that I'm going to discuss are going to be a triangular prism, a cube, and a rectangular prism. So first up here, I'm going to go through our triangular prism. So just to reiterate what we've done in past lessons, if it's a triangular prism, it means that the bases are the top and the bottom of the triangle, right? So the triangle top, triangle bottom, those are your prisms. Those are your bases. So your lateral area going around, your lateral faces are going to be the three rectangles that you see. So it would be like this rectangle here as rectangle 1. Then I'll do rectangle 2 in green, and rectangle 3 in blue. Okay, and there we have it. Now, those three rectangles don't necessarily have to be the same size because your triangle top and bottom don't have to be equilateral. So your lateral area would be to find the area of all three rectangles and then add it together. Surface area would be taking that lateral area, so taking those three triangles and adding on the two triangles. So here's one triangle, and here's the other triangle. Now what we know about these two triangle bases is that they have to be the same. So your surface area would be the lateral area plus the area of the two triangular bases. So 2 times base times height divided by 2. Okay, moving forward, we have a cube. And what do we know about a cube? Well, a cube essentially is just a solid made up of 6 identical squares. So for the lateral area, it's the 4 squares going around the lateral faces. So here we have them going around the lateral faces. I'm kind of outlining them, right? Surface area would be those 4 squares, your lateral area, plus the 2 squares on the top and the bottom, your bases. Now, it's important for me to say at this point that the way I have these prisms drawn, the bases are the top and the bottom, but it's very easy for us to take a prism and turn it on its side, whereas the top and the bottom may not be the bases. So remember, in any prism, your bases are the congruent parallel sides. Okay, so there's your cube. And then finally, we have this rectangular prism. So the lateral area would be the 4 rectangles. So you have one here in the front, one here in the side, one here in the back, and one here again in the side. Find the area of all 4 of those and add them up. If you want to find the surface area, it would be those 4 plus the 2 rectangles on the top and the bottom that I have highlighted here in purple. Okay, remember, to find the area of a rectangle, it's base times height. So we have the lateral area plus base times height times 2 because your top and bottom bases here have to be congruent. So to generalize, how do we find lateral area and surface area for a prism? The lateral area are just all your lateral faces, which are rectangles, base times height. Your surface area is going to be the lateral area plus the area of the two equal bases. Depending on the shape of the base, that formula will change. Okay, so moving on, we're going to talk about now a pyramid, sorry. So for the pyramid, we really have three different types of pyramids. We have a square pyramid, triangular pyramid, as well as a rectangular pyramid. So for the square pyramid, we know that the lateral faces are always triangles. So for your square pyramid, you have 4 congruent triangles around the outsides. So it'd be 4 times base times height divided by 2, whatever your base and height is for that triangular lateral face. The surface area is going to be the lateral area, so those 4 triangles plus the area of the base. Here, the area of the base is a square, so it would just be base times height. For your triangular pyramid down here, you have your lateral area would be the 3 triangular faces. Here they are. And that would be base times height divided by 2. And you're not going to multiply it by 3 because you don't know whether or not those triangles are equal. So it would be base times height divided by 2 plus base times height divided by 2 plus base times height divided by 2. For your surface area, it's going to be that lateral area plus the area of the triangular base, which would just be base times height. Then you have your rectangular pyramid. Again, you have your 4 now lateral faces, which are triangles, so base times height divided by 2. And then to include the surface area, you do your lateral area plus the area of this rectangular base, which is just base times height. Okay, over here we generalize. For pyramid, lateral area are the triangles. And for your surface area, it's the lateral area plus the area of the base. Move on to a cylinder. And for a cylinder, I really refer back to a coffee can. I don't know if you all have coffee cans at home. I have coffee every day. And so I go through the cans a lot. And so when I'm finished with the can, we actually recycle the cans and we use them to store different things in the garage. Like if we have different screws and things like that my husband uses at his workbench. And I always peel off the label of the coffee can. And if you have one at home, if you have a coffee can at home and you peel off the label, you'll actually find something interesting. The coffee can's label is actually a rectangle. So when we do the lateral area of a cylinder, we're actually finding the area of a rectangle. And if you think about unraveling that rectangular label, that length is actually the circumference. It goes around the can, so it's 2 pi r, and the height is the height of the cylinder. So we say the lateral area for a cylinder is very specific. It's 2 pi r h. So 2 times pi times the radius times the height. Now the surface area would be the lateral area plus the area of these 2 circular bases. So we have a circle here, and we have a circle here. Right, so it would be lateral area plus 2 times pi r squared. Okay, and really, if you do have that coffee can, go ahead and peel off that label. You'd be surprised that it's actually a rectangle wrapped around that coffee can. Okay, so here we have our cylinder, our pyramid, and our different prisms. And then we have to also discuss a cone and a sphere. So for our cone, our lateral area is also very specific. It's pi r L, which is that slant height. So that script L represents the slant height. Remember, the slant height goes from that vertex, that apex up here, down to the outside perimeter of your base. It's different than the altitude of the cone. So that's your lateral area. It's pi r L. Look over here. It's actually this sector of a circle to represent the lateral area of a cone. And then the surface area would be that sector plus that circular base. So it's the lateral area plus area of a circle, which is pi r squared. And then finally, for a sphere, we only have a surface area because a sphere doesn't have any bases. So it would just be 4 pi r squared. Okay, so the only thing you really need to know there is your radius, and you're able to find both the volume and the surface area. Okay, so that goes through all the solids and their lateral areas as well as surface areas. So what we're going to do now is take a look at 2 questions. I like to think they're kind of straightforward, but I just want to show you them so we can work through them. All right, so it says the surface area of a sphere is represented by 144 pi. What is the volume in terms of pi? So now this is a question whereas they're giving us the surface area, but we have to find the volume. So I'm just going to scroll up. And remember, surface area of a sphere, we're dealing with the radius. So we're going to take 144 pi, and we know that's equivalent to this 4 pi r squared. So over here, I'm going to kind of set that up. Our surface area is 144 pi. The surface area formula is 4 pi r squared. So I'm going to take those two values, set them equal. And when I do that now, I'm able to divide both sides by 4 pi because I want to get r by itself. And when I do that, our 4 pi's cancel out, and our pi's over here cancel out, and we have 144 divided by 4 is actually 36. So now r squared equals 36. Take the square root of both sides because r is squared, and we find that the radius is 6. Now that we know the radius, to find the volume, we're going to use 4/3 pi r cubed. Make sure r is cubed because it's volume. So we take 6, substitute it in for r, and it's in terms of pi, so I'm only putting in the numerical values. I'm leaving pi, that symbol, out of my calculator. And when I take 4/3 of 216, which is 6 cubed, I am left with 288 pi cubic units. So choice 4. Okay, they do this often. Often they'll give you a volume or a surface area and ask you to find a different measurement, whether it's volume or surface area, however it works out. Okay, and then we have this question, and this is actually a real-life application question. So a painter is hired to paint the walls of a rectangular room. Okay, so think about the room you're sitting in right now. We're going to paint the walls. The room is 10 feet by 12 feet with 8-foot ceilings. If 1 gallon of paint covers 125 square feet, how many gallons of paint does a painter need? All right, so I'm thinking about this, and I'm sitting in a room right now. There are 4 walls, okay? And I need to paint all 4 walls. Now the room is 10 by 12 and has 8-foot ceilings. So take a look at kind of what I did here. I almost sketched a room, right? It's 12 by 10 with 8-foot ceilings. So I have 12 by 8, 10 by 8. Back here is 12 by 8, and then 10 by 8. So that rectangular room is really a prism. If I'm painting just the walls, I'm only painting the lateral area. So the front and the back is the same, as is the left and the right. So look at how I broke this down. My 4 walls consist of 2 walls that are front and back, they're the same, and 2 walls that are left and right, they're the same. My front and back walls are 12 by 8. It's this by this, right? The left and the right are now 10 by 8. So we have 2 times 12 times 8 plus 2 times 10 times 8. And we add that together and we find that the total lateral area is 352 square feet. Now, 1 gallon of paint covers 125 square feet. How many gallons do I need to buy, or does that painter need to buy? So if 1 gallon covers 125 square feet, how many gallons do I need if I have 352 square feet? So again, it's about setting up a proportion. I know this, right? I know for certain 1 gallon covers 125 square feet. I have 352 square feet. How many gallons? So we can cross multiply. We end up with a decimal that's 2.816. So that's how many gallons I need. But think in terms of real life. I don't go to the store and say, hey, can I buy 2.816 gallons of paint? No. We know that that painter must buy 3 gallons of paint. Okay, so this is really how we apply surface area and lateral area to different sorts of questions. Again, please use this lesson to refer back to when you take a quiz or a test. There is no Google form that's going along with this. So again, just you take this lesson, jot down some notes. You could always refer back to this lesson and the answer key should you have any questions. Okay, so again, we just went through the surface area of a sphere, lateral area and surface area of a cone, as well as lateral area and surface area of 3 different types of prisms, 3 different sorts of pyramids, and our cylinder. I hope you can kind of recognize in your head the difference between lateral area and surface area. And should you have any questions, feel free to email me. Take care.